Hello, my name is John Brown and you're listening to the Obscast.
Sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome back to the Obscast, and we're going to move on to the mission with the most desperate reach for an acronym. It's the Jupiter Icy Moons Explorer, or JUICE as it's mangled itself into being called. This is the mission to explore Jupiter with a huge focus on three of its largest moons, Ganymede, Callisto and Europa. JUICE launched on the top of the very reliable Ariane 5 rocket from French Guinea on the 14th of April, and as of recording, it's travelled around 107 million kilometres. It will take 8 years for JUICE to travel to Jupiter, taking the scenic route with flybys of Venus and the Earth-Moon system, stealing gravitational velocity as it goes to help it on its way. So, in 2031, we'll hopefully be hearing news and seeing images from JUICE of Jupiter, and then it will spend 4 years completing flybys of the three moons, Ganymede, Callisto and Europa, ending with an orbit of Ganymede. Lots of science to come from images, spectral imaging, radar images of surfaces. It will be measuring gravitational fields and doing much more science than we would have time to cover here in this segment. But two specific areas of research it will be looking at are the formation of the gas giant and its moons, as well as the possibility for habitable regions on its icy moons. I'd like to know from everyone on the table how important you guys feel this mission is in expanding our knowledge of these systems, or how you think it will compare to past missions such as Voyager, or build on previous missions such as Galileo. Steve?
Yeah, I think this is an absolute fabulous mission. It's going to take 8 years, and it's going to be 2031 by the time we get some information. But I think on development of new technology, I think we'll get some fantastic information. And with it orbiting three moons, we'll gain a lot more information than we have done in the past. Now, the most exciting one, I believe, is Europa. That is probably the top one or two for life. We know it's got underground oceans. It's so exciting to see what they will be able to see in another 8 years' time.
And that's one of the reasons why they're not going to Io, because
Yes.
it's a volcanic, hot, inhospitable, not a water planet as such.
It's not a water world, no.
On previous missions, we've noticed that there's water, there's geysers, there's stuff being ejected into space, all very exciting. And I think this is one of those missions that we've all wanted to happen so that we could try. We all want to find life. Can you imagine the first time they see any sign of any life anywhere, or the signs of life, the stuff that life can make? So it is exciting. It's just 8 years of waiting. So
It is, yeah.
ESA have stated 5 mysteries they would like to explore, and they are: what are Jupiter's oceans world like? Why is Ganymede so unique? Could there be, or have there ever been, life in the Jupiter system? How has Jupiter's complex environment shaped its moons and vice versa? And what is a typical gas giant planet like? How did it form and how does it work? So first off, cards on the table, which of the targets to be examined is going to be the surprise, or is going to surprise us the most, in your opinion? Or out of the 4 targets, which excites you the most to learn more about? I think, Steve, you've just said about Europa being your...
Yeah. I think what we'll find in 8 years' time is amino acids. Now, amino acids is the structure of life, and I'm sure that we'll find amino acids on all 3. Probably Europa is the highest target on that one. We've already found amino acids in the meteorite that landed in the Cotswolds, because it was so fresh, it wasn't contaminated. And the scientists looking at that now have found amino acids, which proves there is the structure of life out there. Now, with Jupiter being so old, and its moons being old as well, it has formed an ocean. So it has formed something, and it's formed ice. Now, what is within that ice and what is underneath it? Because it is warmer underneath the ice than we may anticipate. And
You mean
that's
there's
where-
liquid water?
Yeah, liquid water, yeah. And that's where we will think life is. We got a massive surprise when we saw Pluto. That was absolutely extraordinary. We just thought it was an ice ball. It isn't. And I think we'll be even more surprised when we get close to Europa and the other two that it's visiting. I really do.
If we go through the three moons, it's going to be exploring and discuss them kind of individually, and start with Ganymede. It's the only moon to have its own magnetic field created by an iron core. One point of interest for Juice is that the crust seems to show signs of possible tectonic processes, which of course would be huge. Has a crust made of a thick layer of ice, made maybe even with ice and ocean layered up on top of each other like a little icy lasagna. Under that is a layer of rock, and that rock seems to be in formation to the trained eye, could be the evidence for the previously mentioned tectonic processes. And lastly, Hubble Space Telescope found evidence that it may be saltwater in the icy oceans, and that the moon may have a thin layer of oxygen. Do we have any big Ganymede fans on the table? Anyone here with big hopes for Ganymede?
Oh, I've got hopes for all of them, but we know very little about Ganymede. We know it's the biggest moon in our solar system. It's even bigger than Mercury in diameter, and it's got to be an interesting place. And I don't know much about the conditions on the surface, what the temperatures are or anything else. Not too sure about liquid water, etc. I know we talked about Pluto a few minutes ago, but that's not liquid water as such. It's icy, methane and stuff like this, and nitrogen and whatever. But Ganymede is going to be, I think we're going to learn an awful lot about it, and we're going to spend a lot of time on Ganymede, especially towards the end when we get when Zeus finally settles into an orbit around Ganymede before it finishes its mission. I'm looking forward to hearing about all the moons, to be honest. There's a lot of questions been raised, and it'd be nice to get some answers.
That oxygen layer that Hubble seemed to pick up on is the thing that piqued my interest, because as far as I understand it, there's only one natural way that oxygen is created, and that's through photosynthesis.
Yeah.
Which seems crazy. I mean, I'm sure there must be other ways, but I'm not a biologist. I'm a chemist.
If you think about water, it's hydrogen and oxygen, right? And certain chemical processes can extract hydrogen from H2O, and it'll leave, oxygen. So oxygen is a plentiful thing, but it's just not as plentiful as hydrogen.
Is it rare to find it on its own?
Well, yeah, because it does react with a lot of things and become oxides and stuff. But I mean, I'm not a chemist, but some process may be separating water into hydrogen and oxygen.
But if it's just oxygen, we can't live just on oxygen, because 78% of our atmosphere is nitrogen, and only 21% is oxygen, and it's the oxygen that we survive on. So if only a small part is oxygen, can life revolve around that part of oxygen and a larger amount of another gas? We don't know that yet. We're just comparing ourselves with life,
I think when life started on our planet, and it was bacteria, right? Before complex cells came about, there was about 3 billion years, 2 billion years, something like that, of just bacteria, and they don't need oxygen like we do. Oxygen came about through plants and stuff growing. There weren't plants on
Algae.
our planet initially.
No.
There was life in the sea, there was bacteria and stuff like this, but no greenery, no trees, no grass, nothing.
So Ganymede's interesting, but it's probably one of the most unknown so far, would you think? The next one on my list is Callisto, a very heavily cratered moon with bright patches thought to possibly be ice. Galileo in the 1990s, that's the spaceship, not the astronomer, found evidence for a subsurface ocean that could possibly be interacting with the rock, maybe providing a place for life to form, with the organic compounds from the rock mixing with the salty water. Who knows? Is there a Callisto fan here? possible organic compounds and saltwater mixing, although not for definite. That could be even further of a stretch if you're looking for a habitable place.
The essential thing for life is liquid water, and that's why we're concentrating on planets with surfaces with oceans underneath the surface, where some of these moons are interacting with Jupiter, and it's creating movement inside the planet, it's creating pressures, and that's creating liquid water. And if it's been like that a long time, one thing we've learnt about our planet, there's life everywhere you look, even at the depths of the ocean, deep in rock, everywhere you look, there's different types of life. Life wants to get going. That's the impression we get. And I think it'll want to get going anywhere in the universe. So it's a good place for us to start. The Jupiter moons are close enough for us to get to, and with the technology we've got today, we should be able to discern something. We knew nothing 20 years ago about how moons and other planets were. You know, it was only 50 years ago we were talking about there was vegetation on Mars, you know, canals, etc. And the moon itself was, you know, probably got vegetation on it.
The thing is, Jupiter's so far away, you know, it's 400 million miles. It takes craft about 7 years to get there. And it costs a lot of money. So once you've sent one craft, that's done its exercise. They can't send another straight away, so it's going to be another at least 15 years before we can get a second one there. So this is a long period of time for each mission.
It is, but each one's a learning curve. So you send a mission and they find things that might be interesting, so they develop instrumentation and another planned expedition to go and use the latest technology to look at what they've found, and then they find other stuff, and it's just, that's how it is evolving, really. That's why we're going back. That's why everybody's excited about it. We're finding water out there in our solar system. Who'd have thought it? Very exciting places to go to. We've got a good chance of finding life, and if it exists.
Yeah, I think the most exciting, and I think most other people are mostly excited by Europa. It's a planetary body with an iron core, rocky mantle, and covered in salty water ocean. Which I may as well be talking about Earth when you say that sentence. Apart from all the obvious missing life signs, Europa has twice as much water as Earth total. And while 15 to 20 kilometers depth of that is ice crust, that salty water beneath is also in contact with the rocky surface, creating a magic blend of salt water and organic compounds that are released from the rock. And all the life-chasing fans will know that all that's left to find is the energy input, and you can have life. Well, the huge 100-mile high plumes of water that Europa is spraying do suggest that the internal heat is not an issue, and that there's energy in there, and maybe it doesn't need extra light getting to it. And it's due to the gravitational effect of Jupiter that Europa is getting warm. I think you mentioned another moon with geese, and I think it's Enceladus on Saturn that Cassini saw. It's not just Juice checking out science at Europa, because Europa Clipper is supposed to be launching in 2024, flying through the plumes of water to take a sample, and I'm hoping it gets a fish in their face.
Yeah.
There's a
check from me now.
comical and definitive proof of extraterrestrial life in the universe having a sense of humour, I guess.
Well, it does appear where we don't expect it. I mean, life around hydrothermal vents on this planet was not accepted, and they thought, how on earth could life live at that temperature? But it could, and that's where life probably started on this planet. And just because we don't understand it doesn't mean to say it doesn't exist. Life may like the areas where they live, they get used to it, and they adapt. And we've got to wait to understand that adaptation.
One thing that I did read about some weeks ago now is we can't afford to contaminate a planet with our life forms, however remote that might be, with our spacecraft and our probes and everything else. A lot of this water may be 100 miles underneath the surface of the ice. But to get down there, if we're not careful, we could contaminate an already existing ecosystem with life on it. So each of these moons and most of the planets have got a rating, so maybe 1 to 3 or something like that. And the planets that we're going around, and where we're settling, like Ganymede, has got a certain rating, so that if we do impact on Ganymede, eventually, it's going to affect the fauna and flora of that particular moon. So it is important, because you can imagine if somebody sent something here to this planet, because our planet is teeming with bacteria and microbes and everything else, as we're all aware. We're used to it to a degree. But any other life form coming here, we don't know. But we'd be vulnerable to it, and they'd be vulnerable to us. So it's something we've got to be careful of.
Well, the other target for the mission obviously is Jupiter. We all know Jupiter is massive, it's gassy, has a stubborn storm that likes to show off for a long period of time. And JUICE will be scanning its middle and upper atmosphere all the way up to the auroras and ionosphere, looking at weather patterns and how material is transferred between different layers of atmosphere through waves and other processes. They also hope to gain more insight on how gas giants form. Now, I know everyone here is a massive Jupiter fan, because we never pass up a chance to get it in our sights whenever possible. JUICE will enlighten us to the processes that go on within gas giants. Does anyone here think anything hugely unexpected to come from Jupiter this time round?
Yeah, I just know that the red spot is getting smaller. But it is a massive storm on there since before Galileo's time. But it is shrinking, but it's still absolutely ginormous. It's still bigger than the Earth. But it was about half as big again, so it is getting smaller. But you're talking about probably another 500 years before it even goes away. But there are hundreds of storms around that. You'll see the white band, white blobs, I'll call them, blobs around the red spot, and they are also storms.
Swirly blobs.
Yeah, this is white storms, but they're not as strong as the red spot.
For me, the Jupiter part of it's something I'm not going to know really what it is that's going to come out until they've told us.
Yeah.
You know?
Yeah. Also, we know they've got an aurora at the North and South Pole, and that's the moons that create that, sending voltage to Jupiter. Jupiter tries and get rid of it as quick as it can into all spots, and when it comes earthbound, we can pick it up on the radio astronomy antennae when that's working. But there's so much electricity out there that creates lightning, and that's the North Pole of Jupiter. So it's really impressive when you see the aurora on Jupiter, and that's all created by electricity from their moons, from its moons.
Excellent. Well, thank you very much. I've got one last tabled question for the evening, if that's okay. Speculative. If I came back from the future and told you as far-fetched as it may be, the life has been found on one of the moons and we've discussed tonight, and I want to push everyone for an answer or a guess, which one would you think is most likely to be?
Mine would be Titan, because it's not ice, it's got methane. It said, like you said earlier, bacteria, if it's not restricted, to grow really big. And there's no restriction on Titan, so things can grow really massive. We've already sent a lander there by parachute, and that looks absolutely bizarre. So that's my favourite one, because it's not ice, it just looks like a desert. So that's my favourite, and that's why I think they want to send a mini sub there on a future mission to go into the water and have a look. But that's my number one category, Titan.
Michael, any preference? I did say any of the ones we've been discussing tonight.
I think
we can chuck just random moons in now if you like. Just open that up a bit.
I think don't ask me why, but I've got that funny feeling it might be Europa.
Yeah. Europa's mine. I don't know about you, Steve.
I'm saying the Europa, because awful lot of water there. It's liquid water, salty ocean, and if there's enough warmth there, because all life, we need liquid water and we need energy, and the energy is there too. The minerals are there. We're all made of stars. All around this table are all made of star stuff. Everything in this room is star stuff. Same there. Life has sprung on this planet. It'll spring there and other places.
Yeah. There's well, there's one more thing I think you need for life, and that's time.
Yes.
And Europa
Got plenty of time.
has had plenty of time
Oh.
because it's been there since the formation of Jupiter. So
I think,
same.
I mean, out in space, I think some small red dwarfs that have been around, we're about a third, fourth generation star system. Some of these red dwarfs have been around 10 billion years, longer than
It may
ours.
have had life.
And there's enough energy on planets surrounding these places to really evolve. So I think out there in space, there's got to be a lot of places where life got going well before us.
Europa could have had life for billions of years, but we just don't know it. It could have microscopic organisms under the ocean, but we just don't know yet.
Excellent. Well, on that thought, thank you very much. We'll probably do another episode on Juice in 8 years' time.
Yeah, I'll put it
Before
in my
we,
diary.
I'll put it in now before we get booked up. Before we go for the break, Michael, I wanted to ask you. You're doing some incredible outreach work for the observatory within the Polish community, and it's my understanding you have an event coming up, the Polish School Picnic. Is that right?
Yeah, that's right. Yeah. What would you like to know about it? Because
I would like to know when it is, what kind of work you're doing there, and I think you need volunteers as well. So I think we should plug that for volunteers.
yeah, so it's going to be 17th of June. It is in Polish school in Nottingham. It's called Saturday Polish School, and basically the event is there for the kids because they've got the event every year, and they're trying to connect that with the Children's Day, which is the 1st of June. Also, it's going to be a big possibility for all the Polish organization to promote themselves for the Polish small businesses. And in my opinion, it might be as well a good opportunity for us to promote ourselves as well. So that's why we've been invited to be there. And I'm looking for volunteers to help myself and society to promote us in the Polish community. I've been in Polish school on the 20th of April during the Earth Day. 22nd, sorry, during the Earth Day, and yes, we've got a stall there. We always bringing in loads of leaflets from our society, about what we're doing, about the future, and it's gonna be something like that this time as well. But this time it's going to be outdoors, of course, if the weather's gonna be good enough.
Okay. Well, thank you very much. If anybody wants to volunteer and help Michael out, get in touch with Michael. I guess through the local Obscast group.
Yeah, or the WhatsApp group. Yeah.
Or email. Yeah. Right. So we'll just take a quick break and return for Steve's extremely popular and immensely helpful look up section. We are back, and here on the Obscast, it's time for your personal guide to the stars and planets. It's time for Mr. Lookup himself to shine some extra light on the stars for us all. It's Mr. Steve Smith.
Well, that's a big build-up. Hi there. I started doing my looking up articles in the EH newsletter to inform and encourage members relatively new to astronomy about some of the fascinating objects that become available to us each month over the course of the year. It is wise to be armed and ready with a list of objects containing a mix of favourites and some new stuff to see when the next observing session presents itself. There is always plenty to see if you are aware of what is available. Most of the stuff I'm about to mention today will be in my Looking Up article in June's EH magazine, where I'll go into more detail. Right now, I'm just trying to whet your appetite to go outside and see some exciting objects. Summer is upon us. True astronomical darkness is absent across the whole of the UK during June. We generally aim for brighter objects during the summer as darkness is reduced, but many observations can still be carried out, generally under pleasant, balmy conditions. Galaxy supernova heads up! If you hurry, you may get the chance to observe the bright new supernova. It's called SN 2023 IXF. It's appeared in galaxy M101, the Pinwheel Galaxy, before it gradually fades away over the next month or so. Galaxy M101 is well placed in the evening sky for observing, as it resides in Ursa Major, otherwise known as the Plough, which is almost straight above us at midnight in June. The Type 2 supernova star currently appears brighter than the nucleus of M101. So if you do get M101 in your eyepiece, then look for a star in the right area, and it should be brighter than the core of the galaxy. Please let me know if you get to see it. Moving on, Venus continues to put on a dazzling show in the evening sky. Mighty Jupiter is looking impressive in the morning sky, and Saturn is also back in the morning sky. The Summer Triangle asterism, consisting of stars Deneb, Vega and Altair, is back on the scene, bringing with it such delights as the famous Ring Nebula, we call it M57, and the Dumbbell Nebula, M27. Also, the familiar constellation Cygnus is up there, harbouring the gorgeous blue and gold double star Albario. Also the Veil Nebula, and the Blinking Nebula. The rich Milky Way gives a fabulous background in this area of sky too. Don't worry, these areas are going to be available for the next few months. It's also that time of year to start looking out for noctilucent clouds, which are the highest cloud-like phenomena known to exist in Earth's atmosphere, appearing at around 80 kilometres or 50 miles or so in the sky. In the summer months, water vapour from the Arctic is carried to great heights by the upwelling of cold air, which can plummet to minus 120 degrees Celsius to form ice crystals, which reflect the sun's light. Okay, so this month we have Scorpius and Ophiuchus. They are both at opposition on the ecliptic this month. Scorpius serves up a feast of objects, including both open and globular clusters. I won't list all of them because you'll find all these in the EH in my article, but M4, just to name one of them, it's one of the closest globular clusters to us. It's only 7,200 light years away, and it can be seen with binoculars. You can use binoculars or scopes to view M6 and M7 in this area. They are two bright open clusters in Scorpius, both of which are naked eye objects. This M6 is also known as the butterfly cluster, and for obvious reasons, and M7 is known as Ptolemy's cluster, appearing to the naked eye as a fuzzy spot against the Milky Way background. Globs abound this month. Ophiuchus lies north of Scorpius, but it also encroaches over the ecliptic border, although it's not included as part of the 12 traditional zodiac constellations. But it contains over 22 globular clusters. One of my favourite things to see. Globular clusters are just amazing. Some of the most notable, I'm just going to mention a few. The details about them are in the EH. M9, M10, M12, M14. These are all Messier objects. M19, M62. They're all worth a squint at. So, yes, the skies are light, but these globular clusters you can see. There's a challenge in Ophiuchus, a deep sky challenge. It may like to have a bash at finding. It's about 3 degrees away from star Sabik and another star which is listed in the EH, and it's NGC 6309, the Box Nebula. It's a small and compact with a bluish tint. An 8-inch aperture scope is quite discernible as a fuzzy, non-stellar object against its background stars. Well worth trying to find it. You may need to use a UHC or oxygen 3 filter, higher magnification and perhaps a larger scope, but it's worth having a crack at. And another one of my favourites, elsewhere, in constellation Canis Venatici, is NGC 4244, otherwise known, you may have heard of it, the Silver Needle Galaxy. It's a spindle-like, bright, edge-on galaxy that is well placed this month, and it's worth having a peep at. It appears as a thin, ghostly streak with a bright centre. At magnitude plus 10.4, this is a lovely galaxy to get in your eyepiece's field of view. There are lots more objects along with these, with more info in the June Looking Up article. It will be good to hear from you about any observing sessions you may have had. Wishing you all clear skies and some wow moments. Bye for now. Thank you.
Thank you very much, Steve. Once again, lots for us to get on with and find in the sky.
There's always lots to see. But for me, I found years ago the best thing to have is a list of stuff to find. You can look through star atlases, through apps, look in magazines, get a list of stuff to look at, and then you're armed, you're ready. And it's no good doing it on the night, because what you need is your equipment ready, you need a list ready. And then when you do go out, you know what you can look for: some new stuff, some old stuff, some favourites, and your favourite list gets bigger. And every year you look forward to the same stuff coming around again. So there you go.
Excellent. Thank you very much, Steve, and thank you very much, everyone, for listening to the Obscast. Thank you to all the panel we've had here this evening, and we will see you at our next open day, so keep an eye out on our social media for updates and tickets, and we will see you next time on the Obscast.
Goodbye.
Goodbye. Clear skies.